Hello everyone, my name is Elisa Xu. This is a full recommendation system for DA430 final project. Thank you. The main problem I want to tackle is I want to base down the user what they search and recommend other food to the user. So I will use the from processed data, visualize the results, recommend other foods, search out from Google, and discussion the possibility from this PowerPoint. So here is original data that have 40,000 of the different menus. It have the ID, ingredients of this menu, and what's the question for this food. Here is a package I will use for this recommendation. First of all, I want to explain what is pre-processing data by using the live example. For example, the onion industry, they need to pre-processing those onions by separate those different shapes, colors, or maybe size of it. This is kind of pre-processing. First of all, I will explain what is TF-IDF for pre-processed data. Over here, you can see a very detailed example for what is TF-IDF it is. First, we will state four of the sentence, and then we will filter out the stop words. What is stop words over here is the, is, in, we. So this kind of words can be considered as stop words, and we need to filter out those to rewrite those sentences to be this part over here. The next step is we'll put those letters or those characters to a table. For example, the D1, which is the first rows, we have one of the letter blue and another letter is sky. So we put one for each part. Then usually the words for blue in the first row is half of it. The next step, since we have the 4 rows, which end in 4, so we will use this method to calculate what is the weight, for example, for the blue, what is the weight for the blue in the whole 4 sentence. And next step, we will compute the TF-IDF. And that we are using the half, this number over here, time the number we get over here to get a better number, which is over here 0.301, which represent on the whole column, blue column, and on the whole row, the first sentence, what is the weight score for this blue over here? Why we need to use the TF-IDF over here to do the pre-processing data is because, so right now we know the weight for this character in this column and in this row. Then we can, using the recommendation system, based on this character of the letter, to give some more similar idea of the food we have to the customer. So over here is the example for pre-processing data. We can see a lot of zero over here because not all the menu have those kind of ingredients. But this is just a little bit example on what is the weight score for this ingredients in this menu. You cannot see the menu name, sorry, over here. So here is the code I'm using for pre-process data. I remove all those stop words and get a better result for the process data. So the next step I want to explain is about the PCA. Here is some of the example I find from the online, which I have some reference on the end of the presentation. The PCA we can understanding like we have a lot of prod over here. It is 3D. You can see from this side to see those prods that have a lot of it. But while you make it to be the 2D, it might be just a line. And 1D may be like this kind of line. And the same as this one. You can see a lot of prod in 3D, but while it becomes a 2D, it will be very flat. Just tell you which part have the plot over there. It's not like all over the place. And here is the code I'm using for the PCA, and this is the visualization. So after we finish the pre-processing the data, we need to sort in those data to be a k-mean cluster, which in the live example can be like a kids. They are sorting the different foods to be one category. We are doing that over here. And here is more math method better than the live example. So here is the k-mean cluster code I'm using the row index 0, and they have these 3 recommend food over here. So over here is some of the coding for my search. I'm using the words from 3 based on the weight to search the recommend 10 of the recipe. Then I'm like humanly choose some of the words, then trying to print out their ingredients by the weight. Here is the Google result for one of the ingredients from the previous slide, and it looks like I can get the food from the Google's front page. It is very successful. For this project, I'm using the PCA to reduce the dimension. I'm also using the k-mean cluster to find the similar items and do the recommendation. What I think about the possibility is we can use this one as a case to recommend more grocery food have the same ingredients to the customers. Thank you for your time, and bye.